Alright, the next lesson 6 here. So lesson 6 is only a short one, just one concept, and that is acceleration. Alright, so this is out of the notes there, so there you go, you can see in red the missing word I should say. So acceleration is a quantity that tells us about the change in velocity of an object. So because velocity is a vector, then acceleration would be a vector as well. So acceleration is defined as the change in velocity over time. So in your space there, you should say thus acceleration would be the change in velocity over the time that it takes for that change. So your final velocity minus your initial velocity. Alright, so here's where subtracting vectors comes in over the time. Alright, so to get the units are pretty easy. You combine the units of velocity, which is meters per second, and then time, which is second, and meters per second divided by seconds comes out as meters per second squared, or meters seconds to the minus 2, not minus 1. Alright, so that's about all there is to it in terms of acceleration. Alright, so let's have a look at an example. Alright, in this example, Jack is travelling with a velocity of 2.5 metres per second north, and he makes a left-hand turn, 90-degree left-hand turn. If it takes 2 seconds to make the turn, what is his acceleration? Alright, so assuming here that after his left-hand turn he's still going at 2.5. So initially, his initial velocity, VI, and again I forgot to put my little thing north up the page here. So his initial velocity is 2.5 metres per second north, so his initial velocity is that way, 2.5. His final velocity, if he turns to the left, so if he turns to the left, he turns this way, to the left. So if he turns to the left, his final velocity is going this way here, VF, and that's 2.5 as well, meters per second with the units. Now remember that acceleration is change in velocity over the time. Alright, and the time we know is 2 seconds, it says that right here. So we need the change in velocity. So remember, the change in velocity is our final minus our initial. So remembering what we need to do in terms of subtracting vectors, we need to add the negative VI. So negative VI, the green one's VI, so negative VI would be, so the opposite direction, same size. So the opposite direction, let me draw it in, let's draw it in blue, shall we? So negative VI would be the opposite direction to VI, and still 2.5 metres per second. Alright, so our change in velocity, we've got to add those together. Alright, I'll go to the next page. So it's VF, let's plus the negative of VI. So I'll write that again. Changing is VF plus the negative of VI. Alright, so VF is 2.5 metres per second to the west by the looks of it. So 2.5 plus head to tail, so we'll put the tail of this negative VI, and let's go, here it is, the negative VI. Tail starts up here, and there we're going down there south. So there we are, 2.5 south. So our change in velocity then, from the tail to the head, there is our change in velocity. Alright, we also need to know an angle in here. Alright, so let's have a look. So our old friend Pythagoras says that the change in velocity squared is 2.5 squared plus 2.5 squared. So they're each 6.25. Add that together and you get 12.5. And if we want to find just the change in velocity, we need to square root that, which comes out to 3.54 meters per second. Alright, we need an angle, and use tan again, opposite over adjacent, and that happens to be 2.5 over 2.5, and so you get 45 degrees. Alright, so our change in velocity then will be 3.54 meters per second, and that angle there is west towards south, so west 45 degrees towards the south. Now, it's a little bit of an aside here, that can also be described as south 45 degrees to the west or southwest. So either of those three is fine. Alright, now just let's get back to what we were trying to do. We were trying to figure out Jack's acceleration. So we're wanting to know his acceleration, which is what we started with in the first place here. So it's the change in velocity over the time. So his acceleration is the change in velocity over the time. And so his change in velocity, the size part, 3.54. And the time was 2 seconds. And so 3.54 divided by 2 is 1.77 meters per second squared. And the direction, any one of those three, I'll just use this one here, and his direction is west 45 degrees to the south. Alright, so that's it for this lesson, lesson 6, acceleration. And so on the website, the notes are there on the website, and there's also a couple of videos that cover position, velocity, acceleration. Alright, so have a look at those, and as always, if there's any questions, make sure you ask.